Hello everyone, welcome back to my channel Explain Maths. Now in this video I am going to solve question number 4 of exercise 8.3. So let's begin the class. So my first question is, prove the following identities where the angles involved are acute angles for which the expressions are defined. So you have to prove this identity is true. So in this type of question, what I am going to do, I will take LHS, I will solve it, and we will show that LHS is equal to RHS. Okay, so let's begin it. So first LHS I will take. So my LHS here is cosec theta minus cot theta whole square, isn't it? Now you have to write cosec and cot in terms of sine and cos. So cosec theta, I know it is the reciprocal of sine theta. So it will be 1 by sine theta minus, this is cos theta by sine theta, right? Next, I am going to take LCM. So as both the denominator is sine theta, so it will be 1 minus cos theta by sine theta whole square. Now, if it is whole square, it means the square is on 1 minus cos theta also, and it is on sine theta also. So sine theta whole square will become sine square theta, isn't it? Sine theta whole square is sine square theta. And if you remember, we have an identity cos square theta plus sine square theta is equal to 1. Now from here I can write sine square theta is equal to 1 minus cos square theta, isn't it? Here what I did, I have transposed cos square theta from LHS to RHS. So it became 1 minus cos square theta. Now in place of sine square theta, I am going to write 1 minus cos square theta. So it will become 1 minus cos theta whole square by 1 minus cos square theta, isn't it? Now if you see the denominator, it is in the form of a square minus b square, because 1 I can write as 1 square. So now it is in the form of a square minus b square. And a square minus b square, we know the identity, right? It can be expanded as a plus b and a minus b, right? So here I am going to write it as 1 minus cos theta whole square. Numerator will be as it is and denominator will be 1 minus cos theta, a minus b, and a plus b, 1 plus cos theta. So now 1 minus cos theta, and from here one pair will I can cancel. So I will be left with 1 minus cos theta by 1 plus cos theta, and if you see, this is only my RHS. So it is proved. So this I have solved using the identity cos square theta plus sin square theta equal to 1. Now I am going to solve this next question. Now second question, cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 sec A. So again I will take my LHS. Okay, my LHS is cos A by 1 plus sin A plus 1 plus sin A by cos A. I am going to take LCM. So if I take LCM, it will be 1 plus sin A into cos A. Okay. So the first numerator, if you see, it will become cos A into cos A, which will give me cos square A, plus the second one will become 1 plus sin A whole square. So I will write it here, 1 plus sin A whole square. Now in the next step, I am going to use here A plus B whole square, and I am going to expand it. So it will be cos square A plus, now A plus B whole square, we know that it is A square plus 2AB plus B square, right? So this I can write as 1 square is 1 plus 2AB. So 2 into 1 into sin A. So it is 2 sin A plus B square. So sin square A. And this will be equal to 1 plus sin A into cos A. Now next step, if you see cos square A plus sin square A, we have this identity, right? Cos square A plus sin square A give the value as 1. So in place of cos square A plus sin square A, I can write 1, and then I will write the remaining one, 1 plus 2 sin A. Okay. I hope it is clear. You have to remember the identities. Then denominator will be as it is, 1 plus sin A into cos A. Now 1 plus 1, it will become 2 plus 2 sine A by 1 plus sine A into cos A. Now from the numerator, if you can see, I can take 2 common. So if I take 2 common, I will be left with 1 plus sine A, and in the denominator it is 1 plus sine A into cos A. Now 1 plus sine A, 1 plus sine A cancel, and I am left with 2 by cos A. This further I can write as 2 into 1 by cos A. And 1 by cos A means it is sec A. So 2 sec A, and this is my RHS. Okay. So like this, step by step you have to do, and you have to remember the identity. Because if you solve this question number 4, everywhere you have to use identity. So which identity you have to apply, for that you should be aware of what are the identity, isn't it? So now I'm moving to third question. Now third question, tan theta by 1 minus cos theta plus cot theta by 1 minus tan theta is equal to 1 plus sec theta cosec theta. And there is a hint also given in the question. Write the expression in terms of sin theta and cos theta. So here tan theta and cot theta is given. You have to write in terms of sin and cos. And you know that tan theta can be written as sin theta by cos theta, and cot theta can be written as cos theta by sin theta. So now I'm going to write like that. So my LHS will be tan theta, I can write as sin theta by cos theta. Okay. And cot theta I can write as cos theta by sin theta, plus cos theta by sin theta 1 minus sin theta by cos theta. Now in the denominator part we have to take LCM. So it will become, numerator will be as it is, sin theta by cos theta, and here if I take LCM it will become sin theta minus cos theta by sin theta plus cos theta by sin theta, and if I take LCM here, LCM is cos theta, so it will become cos theta minus sin theta by cos theta. Now it will be sin theta by cos theta. Now this is your division, right? Now if division I will change to multiplication, then sin theta, which is in the denominator, it will come in the numerator, and numerator will come to denominator, right? Plus same way here also, cos theta by sin theta by, multiply by cos theta by cos theta minus sin theta. Now see, this is very important. Many places you are going to use this. Okay, so one small example I can give here. Suppose if it is given like 1 by 2 divided by 3 by 2, isn't it? So it means it is 1 by 2 divided by 3 by 2 in this form. And when you change division to multiplication, it will become 3 by 2. You have to write the reciprocal, isn't it? So 2, 2 cancel. Now your answer is 1 by 3. The same thing I have applied over here. Okay. So this is your division. So sin theta by cos theta will remain as it is. When you change division to multiplication, this denominator will come to numerator and numerator will come to denominator. And same thing I have done over here. Now next what will happen? Sin theta into sin theta, if you do, it will be sin square theta. Okay. So sin square theta, and in the denominator is cos theta into sin theta minus cos theta plus cos square theta by sin theta into cos theta minus sin theta. Now if you see in the numerator, sin theta minus cos theta is here, here cos theta minus sin theta is there. So I can take sin theta minus cos theta common in the denominator if I take LCM. Okay, if I have to make it same, what I can do, here is sin theta minus cos theta, and if here also I have to make sin theta minus cos theta, I can take minus common over here, isn't it? Then this plus sign will change to minus sign. So I can rewrite it as sine square theta by cos theta into sine theta minus cos theta. This plus will change to minus cos square theta by sine theta, and this will be also become sine theta minus cos theta because I have taken minus common from here, and that minus multiplied with plus and it became minus. Now again I will take LCM. So LCM will be cos theta into sine theta multiplied with sine theta minus cos theta. So numerator of first part will become, now see, cos theta and sine theta minus cos theta is already there. Only sine theta is not there. So sine theta, if you multiply with sine square theta, it will become sine cube theta. Isn't it? See why I'm telling, see, in the denominator cos theta and sine theta minus cos theta is already there. What is not there? Sine theta. So this sine theta you have to multiply with sine square theta. So it will become sine cube theta minus, and same way here it will become cos cube theta. Why cos cube theta? Again you see in the denominator sine theta into sine theta minus cos theta both are here. Cos theta is not there. So that cos theta multiply with cos square theta. So it will become like this. Now next what we have to do? Now you can see sine cube theta minus cos cube theta. It is in the form of a cube minus b cube. And what is a cube minus b cube? If you remember, you have studied this in grade 9. A cube minus b cube means it is a minus b into a square plus ab plus b square. We can write it like this. Okay. So a minus b, if I write, it will be, your a is sine theta, b is cos theta. So a minus b means sine theta minus cos theta, and then a square sine square theta plus sine theta into cos theta plus cos square theta, that whole divided by cos theta into sine theta into sine theta minus cos theta. Okay. Now from here sine theta minus cos theta will get cancelled. Okay. So now we are left with, here with sine square theta plus sine theta into cos theta plus cos square theta. And we know this identity, sine square theta plus cos square theta, it will give me 1. It will be 1 plus sine theta into cos theta divided by sine theta into cos theta. And you have to mention here, you have used the identity sine square theta plus cos square theta equal to 1. Okay. Now, if you remember, if it is something, fraction is written like this, 1 plus 2 by 3. So I can write it as 1 by 3 plus 2 by 3, isn't it? This 3 denominator is with both the number. Same way here also, this denominator sine theta into cos theta is with both the number 1 as well as sine theta into cos theta. So I'm going to write it as 1 by sine theta into cos theta plus sine theta into cos theta by sine theta into cos theta. So if you see here, the second part, sine theta into cos theta divided by sine theta into cos theta, it will become 1, isn't it? Because both are same. So I can write it as 1 by sine theta into cos theta plus 1. Now this first part I can further write it as 1 by sine theta into 1 by cos theta plus 1. And 1 by sine theta is cosec theta, 1 by cos theta is sec theta, okay, plus 1. So this I can write it as, I can rearrange it as 1 plus sec theta into cosec theta, and this is your RHS. Okay. So this question was a little lengthy but very interesting question. You have to remember the identity, and you can see here I have used the algebraic identities also, a cube minus b cube, isn't it? A cube minus b cube is a minus b into a square plus ab plus b square. So we will see some of the question where you have to use these type of identities also. Okay, so now moving to fourth question. Now fourth question is 1 plus ck by ck equal to sin square a by 1 minus cos a, and it is given that you have to simplify LHS and RHS separately. So let's do that. So LHS is plus sec a divided by sec a, isn't it? So this I can write it as 1 by sec a plus sec a by sec a. So this second part, same number you are dividing, so it will become 1. And 1 by ck means it is cos a, isn't it? Plus 1. So this is your LHS. Now let's take the RHS. RHS is sine square a by 1 minus cos a. Now we have the identity sine square a plus cos square a is equal to 1. So sine square, if you have to find, you have to transpose this cos square a to other side. So sine square a will become 1 minus cos square a, isn't it? So in place of sine square a, I am writing 1 minus cos square a divided by 1 minus cos a. Now if you see the numerator, it is in the form of a square minus b square. Because 1 I can write as 1 square. So it is a square minus b square. So it will be 1 plus cos a plus b, and then a minus b, which is 1 minus cos a divided by 1 minus cos a. So 1 minus cos a and 1 minus cos a cancel. So you are left with 1 plus cos a. So here you can see LHS and RHS both are equal. Hence it is proved. Clear? Now moving to fifth question. Fifth question, cos a minus sin a plus 1 divided by cos a plus sin a minus 1 equal to cosec a plus cot a using the identity cosec square a equal to 1 plus cot square a. Now to use this identity in LHS, first of all I have to convert this in terms of cosec and cot, isn't it? So just think about it. How will I convert this in cosec and cot without changing any value of this? So we know that cosec is what? It's a reciprocal of sine, and cot is cos by sine, isn't it? So if I divide sine A in both numerator and denominator, then this will be converted in the form of cosec and cot, isn't it? So let's try that. So what you have to do, divide by sine A in both numerator and denominator in the LHS, okay? So in the LHS part, let's divide cos A by sine A minus sin A by sin A will become 1 plus 1 by sin A. This I did in the numerator. Now same thing I have to do in the denominator also. So cos A by sin A plus 1 minus 1 by sin A. So cos A by sin A will become cot A minus 1 plus cosec A by cot A plus 1 minus cosec A. Okay, now I'm going to rearrange it. So it will be cot A plus cosec A minus 1 by cot A plus 1 minus cosec A. Now what I will do in the numerator, I am going to use this identity. Okay, so in place of 1, I will write cosec square A minus cot square A. When I transpose this here, it will become minus and this is equal to 1. So in place of 1, I am going to write that. So it will become cot A plus cosec A. I'm going to put it in a bracket minus cosec square A minus cot square A. Okay, that whole divided by cot A plus 1 minus cosec A. Now see, cosec square A minus cot square A, it is in the form of A square minus B square. So it will be written as A plus B into A minus B. So A plus B is cot A, cosec A plus cot A, and A minus B is cosec A minus cot A. And if you see over here, here is also cosec A plus cot A. So I can take common in both. Here and here, in both the term, I can take cot A plus cosec A common. So when I take that, cot A plus cosec A common, okay, so from the first term I will be left with 1 because from here I have taken this complete common, and here in the second term this can be written as cosec A plus cot A into, I am writing it such that you will not get confused, cosec A plus cot A and cosec A minus cot A, isn't it? So this top part I have taken common, so it means I am left only with this part, isn't it? So I will write here 1 minus cosec A minus cot A, and this whole is divided by cot A plus 1 minus cosec A. Okay, so again the numerator will be cot A plus cosec A, and this will be 1 minus, let me open the bracket, so 1 minus cosec A plus cot A, this whole divided by cot A plus 1 minus cosec A. And if you notice over here, this and this part both are same, only thus there is just rearrangement. If you rearrange, see 1 plus cot A minus cosec A, here also 1 plus cot A minus cosec A. So both you can cancel it. So you will be left with cot A plus cosec A, and this is only your RHS. Okay. So this was also a little lengthy, but this is also a very good question where you can see here, you have, in place of 1 I have used this identity, isn't it? And then my simplification become more easier. Now moving to sixth question. Now sixth question is root of 1 plus sin A by 1 minus sin A is equal to sec A plus tan A. So now here in LHS, I have to rationalize the denominator. Okay. So first of all, you should find out what is the rationalizing factor. And if you remember in grade 9, you have studied, right? Rationalizing factor for these type of values is the conjugate of it. Conjugate means if it is 1 minus sin A, you have to use 1 plus sin A. And if it will be 1 plus sin A, you have to use 1 minus sin A, isn't it? So in LHS, you have to write it as root of 1 plus sin A divided by 1 minus sin A. Now in both numerator and denominator, you have to multiply with 1 plus sin A by 1 plus sin A. Okay, I am rationalizing it. So now it will become root of 1 plus sin A whole square. Okay, and in the denominator 1 minus sin A into 1 plus sin A. Now it is in the form of A minus B into A plus B. So it will be A square minus B square. Your A square is 1 square, which is 1. And B square is sin A whole square, which will become sin square A. Now next is 1 plus sin A whole square, and 1 minus sin square A is cos square A. Again you have to use the identity sin square A plus cos square A is equal to 1. Okay. Now if you transpose sin square to here, it will become cos square A will be equal to 1 minus sin square A, isn't it? So that's what I have used. In place of 1 minus sin square A, I have written cos square A. Now it is root. So from, if I remove the root, it will become, if I find the square root, it will become 1 plus sin A by cos A, isn't it? It is not cos square A, it will be cos A. Now what will happen? Till here I have got. Now after that, again I will write it as 1 by cos A plus sin A by cos A. Okay. Already I have explained why I can write like that. Now 1 by cos A is sec A plus sin A by cos A is tan A, and if you see, this is only your RHS. Okay. So this was a simple question. You have to remember that in such type of question you have to rationalize it. If you rationalize, then only your denominator will be, uh, uh, it will not have any root over it. Okay. Now moving to seventh question. Now seventh question is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So here I can write it as, let's take sine theta common from the numerator. So I will be left with 1 minus 2 sine square theta, and in the denominator if I take cos theta common, it will be 2 cos square theta minus 1. Okay, now 1 minus 2 sine square theta and 2 cos square theta minus 1, both is same. How it is same? I am showing you. See, sine theta by cos theta 1 minus 2. In place of sine square theta, I can write it as 1 minus cos square theta. Isn't it? How? Again, same identity. Sine square theta plus cos square theta is 1. Isn't it? Sine square theta plus cos square theta is 1. And from here, sine square theta I can write as 1 minus cos square theta. So this only in place of sine square theta I have written as 1 minus cos square theta. Now it will be sine theta 1 minus, let's multiply 2 with 1 and 2 with cos square theta. So minus 2 plus 2 cos square theta divided by cos theta into 2 cos square theta minus 1. And from in the numerator if you see, 1 minus 2 is minus 1 plus 2 cos square theta divided by cos theta into 2 cos square theta minus 1. Now you can see the numerator and denominator is same. Just if you arrange it, 2 cos square theta minus 1 numerator will also become, and you are left with sine theta by cos theta, which will give the value as tan theta. So this is equal to your RHS. So that's what you have to prove. So hope you are now able to understand like how to solve these type of questions. So these are not very tough questions. If you practice more and more from some other reference book also, you will find it more interesting and you will feel like solving it more and more. Okay. Now moving to 8th question. Now 8th question is sin a plus cos a k whole square plus cos a plus a k whole square is equal to 7 plus tan square a plus cot square a. So here if you see in the LHS part, both the terms are in the form of a square. So first let me expand it. So LHS will be sin square a plus cos x square a plus 2 sin a cos a. I have used a plus b whole square identity. Now same way the second part is cos square a plus sec square a plus 2 into cos a into sec a. Okay. Now if you see sin square a plus cos square a, this is identity. So it will become 1 plus cos x square a and 2 sin a cosec a. Sin a cosec a can be written as 1 by sin a plus sec square a plus 2 into cos a, and again sec a can be written as 1 by cos a. So this cos a cancel, sin a cancel. So if you take all the constants, so here only 2 is left, here also 2 is left. So it will be 1 plus 2 plus 2 plus cos x square a plus sec square a. So now you have got 1 plus 2, 3, 3 plus 2, 5, 5 plus. Now if you see the RHS, it is in the form of cot and tan. So again I have to use the identity. We know that, right? Cos x square a is equal to 1 plus cot square a, isn't it? And sec square a is equal to 1 plus tan square a. So I have to now write in this form. So cos x square a will become 1 plus cot square a and sec square a will become 1 plus tan square a. So it will be 5 plus 1 6 plus 1 7 plus cot square a plus tan square a. And if you see, this is only your RHS. So that's how you have to solve this type of question. Okay, now moving to 9th question. Now question number 9, cosec a minus sin a into sec a minus cos a equal to 1 by tan a plus cot a. And it is given, simplify LHS and RHS separately. So let's do that. First take LHS. Now cosec a I can write as 1 by sin a minus sin a. Sec a I can write as 1 by cos a minus cos a. Next step, let's take LCM. So for the first term, LCM will be sin a. So it will become 1 minus sine square A. And in the second term, LCM is cos A. So it will be 1 minus cos square A. And 1 minus sine square A is cos square A. If you use the identity, cos square A plus sine square A is 1, right? So 1 minus sine square A will give cos square A, and 1 minus cos square A will give sine square A. That divided by sine A into cos A. So 1 cos A cancel, 1 sine A cancel. So you are left with sine A into cos A. Okay. And I have used again the identity sine square A plus cos square A is equal to 1. From here only, if you transpose sine square A here, it will become 1 minus sine square A. So that value is cos square A, which I have written here. And if you transpose cos square A to this side, it will become sine square A equal to 1 minus cos square A. So in place of 1 minus cos square A, I have used sine square A. Now let's take the RHS part. So it is 1 by tan A, I can write as sin A by cos A, plus cot A, I can write as cos A by sin A, isn't it? Now let's take LCM in the denominator. So your LCM is sin A into cos A. So it will become sin square A plus cos square A. Again, if you see, this is your division. When you change division to multiplication, what will happen? It will become 1 into sin A into cos A divided by sin square A plus cos square A. The denominator will become the reciprocal. Now sin square A plus cos square A, this is equal to 1, isn't it? So it will become 1 into sin A into cos A by 1, which is equal to sin A into cos A. And you can see here your LHS is equal to RHS, isn't it? So that's all proved. Now moving to the last question, question number 10. Now question number 10, you have to prove both is equal to tan square A. So let's solve it separately. So first one is 1 plus tan square A by 1 plus cot square A. So if you remember the identity, 1 plus tan square A is sec square A, isn't it? And 1 plus cot square A is cosec square A. Now sec square A you can write as 1 by cos square A, and cosec square you can write as 1 by sin square A. Again, this is your division. So when you change division to multiplication, what will happen? This part you have to write the reciprocal. So reciprocal of 1 by sin square A is sin square A by 1. So this will give you sin square A by cos square A, which is equal to tan square A. Isn't it? Sin A by cos A is tan, now it's a square. So it will be tan square A. Now the second one is 1 minus tan A by 1 minus cot A whole square. Now tan A I can write as sin A by cos A, and cot A I can write as cos A by sin A. Okay, now let's take the LCM. So it will become cos A minus sin A by cos A, and denominator will be sin A minus cos A by sin A, isn't it? And I forgot to put this all is a square. Okay, now this is your division line. So if you change division to multiplication, what will happen? Cos A minus sin A divided by cos A into sin A, again complete is a square, okay, divided by sin A minus cos A. Now if you see these two part, it is cos A minus sin A, it is sin A minus cos A. And this sin A by cos A, it will become tan A, isn't it? Tan A into cos A minus sin A. From the denominator, I am taking minus common, so it will become cos A minus sin A. And this complete is again a square. This is also a whole square. Now this will get cancelled. So I will be left with minus of tan A whole square. And you know that if the power is a even number, then minus will become plus, isn't it? So answer is only tan square A. And you can see it is in both the cases you got tan square A as answer. So that's what you have to prove. So that's all for today's class. I have solved all the question of question number 4. Now we'll see you in the next video. And if you like my content, please share with your friend and subscribe to my channel. Thank you.